Okay, well, this isn't exactly chapter one, in that the information's not in there, but I think, before you get too far into this, you ought to have some idea of computer organization. Um, so, the main parts of the computer, well, let's see. So we'll go here, call this the CPU. That's the central processing unit. And this is where all the work is done. We'll talk more about that in a moment, but the CPU is the workhorse. Okay, but in order for it to do work, it needs a few other things. So, for instance, you need, some sort of input device. Input device. Okay, now that could be things like certainly a keyboard. Okay, it could be a microphone. Could be a mouse. Could be some sort of video camera. Etc. And let's see, what are joysticks and things like that for games. And so, all of these things could be attached here. Now, there has to be some sort of logic. And so this is the input output bus here. So it just helps organize all these things that are attached to the computer. So you've got an input device and you need an output device. So that you know what the computer has spit out. So definitely we're used to a screen. Okay, but it could be a printer. Could be a speaker, etc. So we can get that the information from the computer out of these different things. And then besides the input going in and the output coming out, a computer needs to hang on to a lot of information, and so it's got to have some sort of storage memory. Okay, and that would hold things like computer files, and well, really they're all files, but you may think of some of them as Word files, some of them as picture files, and so forth, but there's got to be some sort of storage memory that the computer can go out and find and then bring back to the CPU. Okay, so that's the basics. You need input to the CPU. The CPU then has instructions to do. It may need data for that, so in terms of like a program or a file, and so it has to run out here to storage and get that, bring it back. It processes it, it does what it needs to do. Now it may send some more things back to storage, but then it needs to output. Okay, and now the CPU itself, I'm not going to go into great detail, but the CPU itself has its own memory and storage. There's RAM, which is random access memory. And in terms of, doing this work here, up here, it is much, much slower when the CPU has to go to the main disk and get that storage memory, get things from there and bring it back. Now, it's way fast in our terms, but it's way slower than anything that's already in the RAM, or the random access memory. And so, however, this is very volatile. It needs to get swapped in and out and changed all the time for the computer to keep up with all its tasks. But the bigger it is, the more it can hold. And that's why when you start looking at computers, you'll see things like nowadays, 1 gigabyte of RAM. And actually that's getting to be kind of small. It could be 2 gigabytes of RAM, that sort of thing. And then you'll see things like 250 gigabytes of and storage of some kind. Now, that may be the solid state drive. Okay, or SSD. It could be a mechanical unit. Okay, now this one, the solid state drive, is the faster of the two. But the mechanical drive has been much cheaper. And, so I tend to try to get solid state drives because they are faster and all that. But like I say, mechanical drives are much cheaper. And so depending on what you have to do, you may opt for actually a little of both. Okay, so that was the RAM. So the bigger that is, the faster the computer is going to be able to go, because it can grab bigger chunks of the items from, bigger chunks of files and that sort of thing, and hang on to them while it does its processing within the CPU. Let's see. So, well, there's also ROM, which is read-only memory. And now that tends to be for things like just, computer startup and the very, very basics of the computer. You don't tend to deal with the ROM at all, but it is there. There's the control unit that, does exactly what it says. It kind of makes logic out of all this different stuff. There's an accumulator, Okay, this is where the math happens or arithmetic happens. Okay. And then there's something usually called the register, which again is a lot like memory of some kind, like the RAM or like the storage, but it's even smaller. The register is tends to be handling uh, only I think up to 3 pieces of information at a time. Okay. So that's kind of what's happening in there. There's a whole lot more to it, of course, but that gives us the idea. And now, I mentioned the 3 pieces of information. So a given computer word computer words are made up of individual bits. A bit is either a 1 or 0. It's either on or off. Okay, I mean, and it's electrical. So it's either on, it has power, or it's not, or the power is high, or actually it would be I think the voltage. The voltage is either high or it's low. And so that's what happens with a bit, but that given word or that you're working with, so you'll see typically what we have are 32-bit or 64-bit words. Nowadays, you tend to see 64-bit. But again, it's the word is the basic piece of information here, right? And so if I think a given register can only handle up to about 3 pieces at a time, it definitely can handle 2. Well, the bigger the word, the more information you can hold in each piece. And we won't go into it yet at this point. But a word, let's see. So here's a 1, 2, 3, 4, 5, 6, 7, 8-bit word, and it would just consist of ones and zeros. And all the computer engineering and logic and so forth builds from this idea. And so again, if you have a 64-bit word, then you can work with more information at one time. So what do those ones and zeros mean? Well, I don't know. Anything you want them to, pretty much. And that's the beauty of a computer. So that's the basic organization. Again, we're working with computer bits that are either 1 or 0. They're structured into computer words. Again, these days, most of our computers are 64-bit computers. And we have some sort of a storage mechanism. Okay, the CPU here does all the work, actual work, and we need input devices and output devices to be able to tell what the computer has done for us. So that's the basics of computer organization.